calculate the molarity of a solution obtained when 30 ml of 0.5 molar sulfuric acid is diluted to 500 ml. In our laboratory, we dilute solutions. A concentrated solution is diluted with water and we get the diluted solution. Remember, never add water into acid, because a lot of heat is evolved. It is dangerous. The acid will splash out. So, whenever you dilute an acid solution, take water in a beaker and add acid drop by drop with the continuous stirring the solution. In the case of sulfuric acid, you have to cool the beaker because such a large amount of heat is evolved. So, for dilution purpose, we use a simple molarity equation. Remember, it is for dilution purpose. Okay. So, the molarity equation used for dilution purpose to prepare dilute solutions from concentrated solution, to prepare dilute solutions from concentrated solution is this one: volume of initial solution times molarity of initial solution equal to volume of final solution into molarity of final solution. This is only for dilution purpose. Why I am saying is, in equations you should not use this one. When you compare the volume and molarity of reactants, then you have to divide by number of moles. This is only for dilution purpose. So, calculate the molarity of solution obtained when 30 ml of 0.5 molar solution is called semi-molar or hemimolar. 0.5 molar solution is called hemimolar. Sometimes in the question paper they may use such words, hemi or semi. 0.1 molar is called decimolar. Deci, 10 raised to minus 1. 10 raised to minus 2, centi. Okay, 0.5, it is semi or hemi. So, initial solution is 30 ml. Initial molarity is 0.5. Final volume is 500. So, you are diluting it. Final volume is 500. So, what is the final molarity? So, 30 into 0.5 equal to 500 into M2. You see, this 500 and this 0.5. Okay, it goes 1,000 times. Yes or no? Yes. Therefore, you see, final molarity of the solution is, what the final molarity? Therefore, final molarity of the solution is 30 by 1000, or it is 0.03 molar. You see, semi-molar become 0.03 molar. So, you are preparing dilute solution by using molarity equation. Remember, it is only for dilution. Never apply this V1 M1 equal to V2 M2 for solving the volume of reactants involved. There, suppose you have reactant A and reactant B combined to form product, the number of moles and volume are related as what? Volume of A into molarity of A divided by the number of moles of A equal to volume of B into molarity of B divided by number of moles of B. Then only it will be correct. Okay, hope it is clear? Yes. So, we had discussed 7 concentration units, their formula, and a simple problem for calculating molarity of dilute solutions. We will be doing more and more of practice problems under concepts and snippets for throughout this year, throughout these chapters. remember, we have totally 16 chapters in plus 2. So this is a very good practice of introducing important concepts with the theory followed by a numerical wherever it is possible. Otherwise, we'll focus on theory. For P block elements, we'll be doing the theory followed by a reaction. Okay. Thank you.